Okay, so this is 10.2 and it's titled Biodiversity at Risk. So the objectives for today are going to be define and give examples of endangered and threatened species, describe several ways that species are being threatened with extinction globally, explain which types of threats are having the largest impact on biodiversity, list areas of the world that have high levels of biodiversity and many threats to species, and then compare the amount of biodiversity of the United States to that of the rest of the world. Okay, so in the last section we talked about what biodiversity is, and it's just the diversity of life in a certain area. And specifically, you have the idea of extinction. And whenever you have extinction that occurs over a short period of time, and it's a large amount of species that get eliminated, that's going to be called a mass extinction. So throughout Earth's history, we've experienced several mass extinctions, and kind of the unifying factor in all these mass extinctions is typically going to be some sort of global change to the climate. And that global change to the climate can happen immediately, or it can be something that kind of happens more or less gradually. And whenever you have one of these mass extinctions, it can take up to millions of years for the biodiversity to recover to levels that were similar to before the extinction. This is a map, or a graph giving you an idea of mass extinctions over time. So this dashed line right here is what's known as the background extinction. The idea of a background extinction is just that extinctions happen all the time, and they aren't necessarily, not necessarily a mass extinction. So, there's always going to be certain amounts of species that just for whatever reason aren't well adapted to a certain environment, so they're going to become extinct. Or you might have little small scale disruptions in the environment that can cause those species to become extinct. So that's going to be what this dashed line is. But the mass extinctions are going to be these large peaks. So in here you have 3 really large mass extinctions, and then 2 or 3 smaller peaks. That's occurred over the course of 600 million years. And right now, scientists are warning that we're in the middle of a mass extinction currently, where that the rate of extinctions has increased by a multiple of 50 since 1800, with up to 25% of all species on Earth potentially becoming extinct by 2100. So between 1800 and 2100, up to 25%, so up to a quarter of all species on Earth could become extinct. So obviously 1800's already happened, so we're in the middle of this process where we're not up to 25% yet, but we've certainly had a large amount of species on Earth that have become extinct due to human causes. And so the rate of extinction has increased so much since 1800, largely because the human population has increased so much. And what caused the human population to increase so rapidly is increases in technology and better hygiene, and so those are all good things for humans, and you certainly don't want to downplay those, but there's certainly consequences that can arise when you have the human population expanding so rapidly, and when we use the environment for our expansion and we don't use the environment in a way that's sustainable or healthy for ecosystems. And so again, what's unique about these current mass extinctions is that they're the only ones that humans are the primary cause of. Whereas the ones, these other ones, these are just caused just by kind of just changes in the environment that just happened over time. So you think of the dinosaur extinctions, where they predicted it was some sort of massive asteroid that hit the Earth and that changed the climate suddenly. So things like that weren't necessarily caused specifically by humans, because humans weren't really around then to cause all those. Okay, so what species are going to be prone to extinction are going to be smaller species, smaller populations of species that are in limited areas. Meaning that if you're a larger population, you're just more likely to be able to survive some sort of extinction event. If there is some sort of massive hurricane that happened and you're in a larger population, if that hurricane wipes out half of your population, well, you still have, if it's a larger population, you have a larger number of individuals that survive versus if that hurricane wiped out, half of a smaller population. And it's also, extinctions are going to target small populations that are in limited areas. So populations that have to have a very specific area in order to survive, meaning that they aren't very flexible to changes in the environment. Whereas if you're a larger population, or it's a population or species that can move areas easily, then if the area that they may prefer gets put in danger, then they can just as well move to a different area and continue on living. So again, a species that are increased rate of extinction are going to be those that need large or special habitats, or those that have to migrate. Maybe there's certain, say it's a certain population of birds or something that they have to migrate to a specific area during winter. Well, if that area where they migrate gets eliminated, then that's going to put them in danger, because they get to find a new area to go to during the winter. Or you also can think about, they have essentially two areas that they have to be in, because they're going to be at risk because they have their area that they want to be in before they migrate, and then they have a second area they have to go to whenever they do migrate, as opposed to a species that sticks to more or less one area or can move to a different area. They're just more flexible. They don't have like two homes that they need to survive for them to be able to live and reproduce. And also species that live in areas that are of specific use to humans and that are exploited by humans. Oh, also, finally, the idea of the large habitats. So any species that wants to travel over large distances, that needs a huge swath of land in order for it to survive, is going to be at a greater risk, because the likelihood, if you need a larger area to live, the likelihood of that larger area, the likelihood of your area getting exploited or getting ruined is going to be greater than if you're someone who's content with a species that's content with a smaller area. Okay, so then kind of the categories that we put species into. Endangered species is going to be the most specific category, and so those are going to be species that they are, the idea of them going extinct is present right now. It's happening right now, and so we put together these protections or measures to try and specifically protect these species, because it's not a matter of, well, maybe they might become extinct. It's, if we don't do anything about it, they will become extinct. Whereas a threatened species is more of a species that their numbers are dropping, but it's something that's more of a theoretical if they're going to become extinct. So a threatened species is a species that's kind of on its way to becoming endangered, but we haven't quite jumped over that line to where we would call it endangered. Okay, so how do humans cause extinctions? So again, past 2 centuries, the human population has just grown rapidly. And so, a lot of how humans cause extinction isn't necessarily, this intentional, evil thing, so much as there's just more people. And if there's more people that need to find homes that are going to move to areas where humans aren't at. And so as humans move into a different area, they change that environment to meet their needs. You might have a forest that, it's just a forest, but, you get a new population of humans that go there, and they're going to start removing trees or altering that ecosystem to fit their purposes. And again, it's not so much that it's like, well, we hate the environment, we're doing this on purpose. It's just, we're trying to survive too as humans. However, there is kind of some more specific stuff that humans can do that goes kind of above and beyond just general human growth. So things like pollution, where we're not being smart about how we're getting rid of certain chemical pollutants, or we'll introduce non-native species. So a native species is something that's natural to that area. So a non-native species is where you bring in a species from where, from some other area where that species, isn't normally in the native area. So kind of an example could be whenever, Columbus found the New World, founded the Americas, and, people came over from Europe, they brought with them, livestock and different types of plants that were native to Europe, but they were non-native to the Americas. And so that introduction of those non-native species kind of, flipped the game on its head. All of a sudden you have plants that are, plants are having to compete with other plants. You have different types of new cattle that's competing with, cattle that's in the American, over in the American continent. And so, or you have over-harvesting of species, so things like over-hunting or not using the soil properly. And we'll kind of talk about a little more specifically these in the next slides. Okay, this is just a little table giving you an idea of all the different types of species and where they're at in terms of the percent of species that are going to be threatened. So the big ones are going to be the mammals, your plants, and your birds. And as you think about this should make sense to you because, mammals, we like to eat mammals. That's something that's a big source of food for us. Plants are a big source of food for us, and so these, and birds as well. And so these are going to be species that are going to be at an increased risk of becoming extinct because we're hunting them, but also because they're limited to a certain area, and they don't reproduce as often. So mammals and birds, they typically don't reproduce nearly as much as something like a fish or an insect or some amphibians, and they also are more limited to a specific area. Plants, they have, plant seeds can get dispersed by different animals and, through things like the wind and stuff. But for the most part, like during its life cycle, plants, stationary in one spot. So if you have, human populations that come in and remove those plants so that they can build their house, there's not really a whole lot that plant can do about that. Whereas the things like insects, people aren't going out and illegally hunting insects. That's not really an issue we have, because most people in the world don't rely on insects for a substantial amount of their food. Okay, habitat destruction and fragmentation. So as I said, as humans grow, they're going to be using the land to build their homes, and they're going to be using the land to get their food and to grow resources that they can sell to make profit on. And it's estimated that around 75% of extinctions that are occurring right now are due to habitat loss. They're due directly to humans moving into an area where humans weren't there previously, and then altering that landscape to build their homes and use it for their resources. So that's the biggest cause of extinction is going to be this habitat destruction. So that's kind of the biggest area for improvement. And kind of the classic example is the cougars, the Florida cougars, including the Florida panther, where these cougars like a very large and broad habitat to survive. They like to have a large area where they kind of roam and they hunt for their food. Because of that, if humans come to that area where those cougars are, and they build their fences, they build their roads, they build their canals that break up that land that the cougar was used to just kind of free roaming, that impacts that cougar's way of life. It impacts its probability that's going to be able to survive. So in 2011, it was estimated there's only about 150 Florida panthers left east of the Mississippi River. So then you have the idea of an exotic species. So an exotic species is just a species that's not native to a particular region, meaning that any species can be an exotic species depending on which location you're talking about. So, even like a cat or a rat, so say a cat, you have a certain cat that's native to Houston, so that cat would be native to Houston, but it would be an exotic species if that cat ended up in China or something. Same goes for a certain rat. So an exotic species is just referring to, an area where that species goes where that's not its native region. And so, as I mentioned in previous slides, exotic species are going to threaten the native species because it's increasing competition between those species. Or they're all of a sudden there's like a new, kind of a new dog in town that they're having to fight for their livelihood, having to fight for their survival. And these native species don't have natural defenses against these exotic species because you got to think about evolution here, where you have with your native species that ecosystem developed together. Those plants and those animals, they co-evolved. That was kind of a word that we've talked about in the previous semester, where the two species, because they're in the same ecosystem, they both influence one another's evolution. So, if a certain species of plant develops kind of some sort of chemical releases at an insect that's trying to eat on it, that's something that plant evolved to fight that specific species of insect. That chemical was targeted at that specific species of insect. But say you have an exotic species of insect, some non-native insect that you bring into that ecosystem, that plant, may not have that natural defense, may not have that chemical secretion that it can secrete that will be able to attack that non-native or that exotic species of insect. So another area, way that humans are going to be influencing extinction is going to be overhunting, and especially the idea of poaching. So poaching is the illegal harvesting of fish, game, or other species. So basically, the government will identify a certain type of species that is endangered, and they'll say, hey, this species is near extinction. We need to, we need to limit or just completely eliminate anybody being able to hunt these species for food or for profit. However, just because there's a law that says you can't do that doesn't mean that people are going to all follow it. So, illegal hunting of endangered species happens all the time. Especially over in India with the ivory trade. Where you have the hunting of elephants is illegal over there, but people like ivory, people like the tusks of elephants. It's kind of a valuable commodity, so people will do poaching. They'll illegally hunt those for profit. And other examples are going to be different pets, or especially different types of herbal medicines that people will harvest illegally just because they're rare and they can make a profit off of it. Okay, then the idea of pollution. So especially in our industrialized society, there's all different kinds of chemicals that we use, different types of pesticides that we put in our crops, cleaning agents that we use in our homes, drugs that we use to keep us healthy, chemicals that we might use, to make things like plastic and stuff. And if we don't dispose of these chemicals properly, they can lead to pollution. They can end up in ecosystems, or they can affect the species there. So they might, if a company doesn't dispose of them properly, they could just get dumped into, some sort of river where they can fall down to the bottom of the sediment and accumulate there. Or an example here is DDT, which is a pesticide that's illegal for use in the U.S. Now, but back in the day, it was a really effective and really cheap pesticide that was used. And especially it was effective in fighting mosquitoes. However, a consequence of DDT was that it was killing off a lot of bald eagles, and it was even toxic to human use. If humans were exposed to DDT, it's not healthy for humans. And so that's kind of an idea of the example of the long-term effects of these chemicals that we don't necessarily know until many years after. So I mean, there are tests that go on when we're going to use a chemical whenever we're making a product, especially something like a cleaning agent or a drug. But even whenever we run all these tests on these chemicals, there's still kind of that unknown where just because of time and money, we may not know, the effect that chemical might have 30, 40 years from now, or how we tested that chemical. We may have tested that chemical on like a rat or a mouse, and we can't, for ethical reasons, have tested that chemical on humans. So we don't completely know how it's going to affect humans once you use it on humans, or especially how it's going to long-term affect humans. Okay, so areas of critical biodiversity. So there's going to be certain, biodiversity, as we talked about, it's not evenly spaced out throughout the world. There's going to be certain areas of the world that are going to have higher proportion of species, higher proportion of biodiversity. An endemic species is going to be a species that's native to a particular place, and it's only going to be found there naturally. So ecologists use endemic species, especially plants, as an indicator of overall biodiversity, which should make sense. I mean, if you have more native plants and animals to an area, that's going to increase that's going to be a higher amount of biodiversity than an area that has fewer native plants or animals. And they specifically are going to use plants as an indicator because of our energy pyramid that we've talked about before, where plants make up this foundation here, whereas all the consumers that are going to be above the plants, kind of like your different types of animals and stuff, this area right here can only be as large as the foundation of plants. So they specifically are going to use plants because the consumers are dependent on the plants. So the tropical rainforest is going to be the largest area of biodiversity. So over half of the world's species are going to live in these forests, even though they only cover 7% of the Earth's land surface. So over half of all the biodiversity is concentrated in only 7% of the Earth's land surfaces. And many of the species in tropical rainforests we don't know about. We haven't been able to adequately describe and study these species. Yet these species are still disappearing because the tropical rainforest is being cleared for farming and cattle grazing. And another thing to consider other than biodiversity is that there's native people who they base their lifestyle, how they survive and how they make their money on these tropical forests. So, if we as humans are kind of going into these tropical rainforests and are clearing them for our own purposes, there's very real consequences to that. Another area of high biodiversity is going to be your coral reefs and your coastal ecosystems. So coral reefs, they're some of the most beautiful areas of the world. They're areas that people like to go to for tourism. And so if you start removing these coral reefs, you're not only going to be removing areas of biodiversity, species that might hold a certain type of coral in a reef that might hold some next new breakthrough in medicine. But you're also going to be removing beautiful tourism spots where local people rely on those areas for their way of living, for their economic purposes. And so, humans affect coral reefs just how they affect other areas by things like pollution, so not getting rid of their chemicals properly, and then just developing along these waterways. As you either they're literally building stuff on these coral reefs, or they're building things nearby these coral reefs, where the process of developing those cities or whatever they're building will damage those coral reefs. And then you also just going to have overfishing, where you're just removing too many fish from that ecosystem. So it's again, it's kind of like a Jenga tower, where if you start removing too many bricks from that Jenga tower, any one brick might not cause a tower to fall down, but if you keep removing too many bricks or too many strands from that food web, eventually the whole ecosystem can come falling down. And then, similar type of thing is going to happen with your coastal ecosystems. So things like your swamps, your marshes, your shores, and your kelp beds. But it's going to happen more significantly in the coral reefs. Okay, so islands. Islands are going to be areas that they start off with a fewer number of species. So maybe you kind of have just a few little species, but then they branch off over time. As these species evolve, they're going to branch off into, maybe three species turns into 50 or something. But these populations on islands are going to be very distinct, and they're going to typically be limited species because, an island is separated from land by all that water. So it's not as if species can just be walking across the water to get to the island. So you're only going to have a few species that are going to initially colonize that island. but then those species can then kind of diversify into different types of species. And so because islands are going to be isolated from other areas of land, they're going to have typically more exotic or really unique species that are going to be on these islands. However, these island species, just an example is the Hawaiian honey creeper, are going to become endangered from these invasive exotic species, so these species that are non-native to that island. So Hawaii, Hawaii were just islands that really were more or less not touched by human activities until, we as humans more and more conquered, so to speak, the Hawaiian Islands, and use the environment for development and our growth, and by doing that, that endangers species. Okay, so biodiversity hotspots. So the idea of a biodiversity hotspot is just identifying areas in the world that have the highest density or the highest amount of biodiversity. So it's going to be your tropical rainforest, your coastal areas, and your islands are typically going to be areas that are going to be hotspots. The idea of the label for hotspot was developed by an ecologist in the 1980s. And most of these hotspots have lost at least 70% of their original natural vegetation, which is a lot. 70%, that's over half. So these areas of high biodiversity, they've already lost most of their natural vegetation. And this is just a map of the world of all the different biodiversity hotspots. So for the U.S., you have some in California, and then some over here, especially in Florida, like the Florida Everglades. So biodiversity in the United States, you have the Florida Everglades, as I mentioned, different coastal regions in California, Hawaii, Midwestern prairies, and then forests in the Pacific Northwest. The U.S., interestingly enough, we have high numbers of freshwater fishes, mussels, snails, crayfish, and also a large diversity in land plants like pine trees and sunflowers in comparison to the rest of the world. California floristic province has right around 3,500 native plant species, and of these 3,500, over half of them are endemic, or they're endemic means native, so over half of them are native to that area, and then 565 of those are threatened or endangered. And the threats to this area are kind of the same old thing, Dam construction is a unique thing in California, along with overuse of water, but things like destructive recreation, agriculture, and housing, mining is a little bit more of a unique one, but a lot of these are just general, they apply to all different types of areas throughout the world. Okay, and that's going to do it for 10.2.